Okay, my name is Chris Thrawn. I teach mathematics at Texas A&M University Central Texas, and today I'm going to talk to you about student mathematical modeling projects with interactive Excel spreadsheets. Let me give an overview. I'm going to talk about two semester-long projects with two different students, Kara Klinke and Danny Salinas. The motivation for these projects, my primary concern was to address a meaningful, practical problem relating to the student's chosen profession. I wanted also to demonstrate that math modeling can enhance practical policy decisions, helps you make good choices. I also wanted to come up with something that was useful, that others could use, that could actually benefit from this project. All right, so the methodology that we used, the Excel spreadsheets that we used were programmed using Visual Basic. The reason that we chose this methodology was that both students had prior programming experience with Visual Basic. And we didn't want to get bogged down in the programming. We wanted to do more with the mathematics. The other good thing about Excel is that no matter what job you have, whether teaching or industry, most likely you will have Excel on your computer. A nice thing also about Excel is it has a good user interface. You can type things into cells and arrange things nicely to make it easier for the user to use. Okay, so here's Kara's poster. They presented at a research conference, and here's the completed posters. Let me go into some of the items on that poster. So the practical question Kara was addressing was, do teachers grade enough homework, tests, etc. to give an accurate grade? All teachers grade, but sometimes they don't really think about whether they're about their grading scheme. Are they grading too much? Are they grading much more than they need to in order to give an accurate grade? Also, teachers use different ways to grade. Sometimes they'll drop the lowest grade, or sometimes schools have minimum grading policies that award a minimum grade to the student no matter what they do. In fact, in 2010, there was a Texas court decision prohibiting minimum grading policies, so this really was a pertinent project. So we wanted to evaluate the effect of these different grading innovations. Okay, so she designed a user-friendly spreadsheet that uses teacher inputs on assignments and students' performance, and the way that the probabilistic results were generated was Monte Carlo, repeated random trials, and these trials were performed in Visual Basic. And the spreadsheet outputs the mean and standard deviation for different student profiles. Okay, I think the best way to introduce you to Kara's project is to show you the actual spreadsheet. Okay, here it is. So let me show you how it's organized. In this yellow section, the user will input their assignment information, basically grading scheme information. For instance, in this particular semester, there were 1, 2, 3, 4 homework assignments, 1, 2 quizzes, 1 test. The topics covered by each of these assignments is listed here. The total point value for each assignment is listed here. So each homework was counted the same, each quiz was counted the same. I'll have this quiz count 100 and this test count 100. All right. Completion points means that if the student simply hands in the assignment, they get at least this many points. Now on a quiz or a test, usually you don't have completion points, so we put a 0 there. The number of graded items says how many, basically how many questions there were on the test, on the assignment. And since we're doing quiz and test, or say the quiz has 10 questions and the test has 20 questions. Number of partial credit levels per item. For instance, this one here indicates that the student either got the question right or wrong. All right, in this case, we'll say that the teacher allows 3 partial credit levels. They get 33%, 66%, or 100%. So we'll put that for both quizzes. And let's say on the final test, the teacher is more careful about grading and there are 5 partial credit levels. The question is, does the teacher drop the lowest item? If the student does badly on one question, does the teacher drop that grade? So we'll say that the teacher drops the lowest question on the quiz and the lowest 2 questions on the final test. All right, and the last one says, is there a minimum score on the assignment? And we'll say no, there's no minimum score. Okay, so that's what the teacher or the user of the spreadsheet would input. Here's some additional information that the teacher would input. how do the different types of assignments, homework, quiz, test, count on the total grade. By the way, you can create your own assignment types, and the spreadsheet will automatically add those. For instance, I could have a final exam assignment type. As long as my types are consistent in the different sections, it will count that up also. So homework, let's say homework is 20%. Let's say the quizzes were 40%. Oh, that's too much. Let's say quizzes is 30%, and the final test would be 50%. And here are your minimum A, B, and C scores. Minimum passing score is 60. All right, now here's information about the students. This is your best guess as the student's actual proficiency. So what you want to do is see how your grading scheme reflects the proficiency of the student. So here, the first student is kind of bare passing student, and then at the end he tails off and does below passing work. So let's do student 4. Let's say student 4 starts out very strong, but then loses interest and goes down to 40, like that. And we'll see if he passes. Okay. All right. These are assignment completion percentages. Does the student actually hand in his work? And let's say the new student that we're adding. So let's say he doesn't turn in 10% of his assignments. He turns in 10% just for minimum grade. Does minimal effort on it. I'm going to leave anxiety factor now. That's basically to account for test anxiety. And let's see, that's for homework. For quiz, let's say he does all his quizzes, so we'll put zeros there. Okay, now here are the results. In order to get the results, we need to run a macro. We go up to the View tab, go to Macros, View Macro, and run the macro that's there. What the macro does is it runs several simulated semesters. I think it runs 1,000. You can change that parameter in the Visual Basic Code. And then we can see the result. That's the expected grade of our student, and that's the standard deviation. So here's his probable grade distributions. He actually has a 97% chance, 98% chance of passing. It's a 35% chance of getting a C, and minimal chance of getting a B or a A. Okay, so we can use this tool to evaluate different grading schemes. Okay, here are the results of 2 preliminary studies that Kara conducted. On the left, you can see effect of amount of homework graded on accuracy of grades. This was comparing the amount of homework graded and the effect on accuracy of grades. And so you can see actually that the blue bar compared to the red bar on the left, if the teacher only graded 50% as much homework, there really was a minimal effect on the accuracy of the grade. On the right, effect of minimum grading policy on passing rates, you can see for different student profiles the effect of minimum grading policy on passing rates. And for some of the students, there was a huge effect of the minimum grading policy. That, for instance, on the very first student profile, with the minimum grading policy, over 40% of such students passed. Without minimum grading policy, only almost 0% of the students passed. So there's in some cases, huge effect of minimum grading policy. Okay. So the idea is to use this spreadsheet as a rational policy choice tool for deciding about the impact of grading schemes. Okay, let me move on to Danny's project. The title of his presentation was How Much to Fix My Car, Estimating Repair Costs. Here's the poster that he presented at the Texas A&M Research Conference. Okay, the motivation for this project. If I'm faced with the decision to buy a new car or stick with the clunker I have, in order to make a good decision, it'd be helpful to know what repairs would cost if I keep the car. So we developed an Excel spreadsheet that used a reliability model to estimate repair costs over the next year. And of course, you can't tell exactly. We also give the error bars for the estimate. And our methodology was tested out on the Toyota Camry because basically that's what we could get data for. So we actually got data off the web from a site that compiles data from users. We got repair cost data also from the web. The reliability model assumes that the different repair types are independent, and we assumed a probability distribution for each repair type, and we fit the parameters of the probability distribution from the data we obtained from the web, and we processed that using Excel, using MATLAB, and exported the results to Excel. Okay, So let me show you that spreadsheet. So here is the user interface for that spreadsheet. This is what the user can put in. So for instance, suppose my car currently has 95,000, and I estimate at the end of the year it will have 130,000 miles. Suppose I live in a area where the expected cost of repair is low, relatively low. All right, and this gives the expected number of repairs, standard deviation of repairs, expected total cost, standard deviation of repair cost. Another thing that the user can do is put in past repairs. The different repairs are listed here. And if you've had a repair previously, then you can put that in here. For instance, battery replacement. Suppose I had my battery replaced at 50,000 miles. Suppose I had fuses replaced at 60,000 miles. Okay, so I go down here. Suppose I had a brake pad replaced at 80,000 miles. So I can go in here and put my previous repairs. Okay, and then up here I'll have my results. My result is I expect to have 3.47 repairs over the next year. Standard deviation of repairs is almost 2. So if you do 2 standard deviations, that's basically between 0 and 7 repairs, something like that. Expected total cost of repairs is about $850. Standard deviation repair cost is $500. We also have some graphical representations. Here are different possible electrical expenses and the expected electrical expenses. We don't have error bars on this. That was a little too hard to show. Expected engine expenses. So this is kind of a breakdown of expenses. We also have a breakdown of probabilities. For instance, alternator replacement, you have greater than 10% chance of having to replace the alternator, and so on. Okay, so that pretty much wraps it up. If you are interested in obtaining this PowerPoint or the original student presentations, you may obtain them at the web page listed, www.tarleton.edu/faculty/Thrawn. If you're interested about the spreadsheet and details of the spreadsheet, the programming, etc., or if you want a copy of the spreadsheet, please email me at thrawn@ct.tamus.edu. Thanks very much. Hope you enjoyed the presentation.